The hydraulic system currently on the FT8 is used exclusively to actuate the inlet guide vanes and variable stator vanes. Some of the older FT8 units also had their gas and liquid fuel valves controlled electro-hydraulically. Most industrial turbine manufacturers now use electronic actuators and eliminate this complete system. Once you get the FT8 unit on load, the hydraulic system is not used again until you are shutting down, so a lot of energy is used unnecessarily. Modern aircraft still have hydraulic systems, so it makes sense to use hydraulic actuators on aeroturbines. The hydraulic system uses the same oil as the GG and PT. It even takes its supply from the pressure side of the GG lube oil pump. That means the supply pressure entering the hydraulic system is 46 pounds per square inch. Because the hydraulic system is piggybacked onto the main lubrication system, it shares a lot of the components with it. In the drawing you will not see a tank or cooler as these are part of the GG and PT lube system. The two dotted boxes represent the limits of the pump and servo assembly, which is driven by the accessory drive gearbox under the turbine. Oil enters the suction of the hydraulic pump at 46 pounds per square inch, and is increased to 750 pounds per square inch by the pump. Because it is a positive displacement pump, there has to be a pressure relief valve PRV501, which will open to relieve pressure in excess of 750 pounds per square inch. There are two pressure transmitters, PT501 and PT502, one either side of the hydraulic filter F501. The controller logic uses the difference between transmitter reading to determine the differential pressure on the filter. The filter F501 is 25 micron, with a 50 psi differential bypass, PSV501. The bypass valve ensures that there is a supply of oil, even if the filter is blocked. The pressurized oil then passes into the twin servo, and passes check valve CV502. The check valve will shut in an emergency if the pump fails, preventing loss of pressure from the accumulator ACM501. The accumulator will smoothen any pressure ripples, and is a store of energy to open up the IGV and VSV in case of a pump failure in service. Oil flows into each servo valve, and CV503 keeps the two servos separate. Each servo directs the pressurized oil to one side of the actuator, extending or retracting it. Whatever side is pressurized, the other side becomes the return, allowing oil back to the tank. In this photo you can see many of the components discussed so far. Dual servo, hydraulic pump, hydraulic filter, control signal to servo, connecting lines to IGV and VSV actuators.